Hi students, in our yesterday class we are completely discussing about crystallographic methods. Crystallographic methods are used to determine the structure of the crystal. Originally the actual structure of the crystal. So in crystallographic method we are studied in our last class. First method is lace method is completed. Second one is X-ray spectrometer, diffraction spectrometer is completed. And next one, from these two experiments are used to determine the structure of the crystal. First of all, structure of the crystal. In two experiments there existing some drawbacks, that is called as you can determine the structure of the single crystal only. You can determine the structure of only single crystal, and if the defect is existed in the crystal, if any one of the defect is existed in the crystal, this defect is not identified by using these crystallographic methods by lay method and X-ray diffraction method. So based on the diffraction drawback, we are going to the next method is rotating crystal method. Rotating crystal method. This rotating crystal method is used to determine structure of the crystal. First of all, it is used to determine the structure of the given crystal. Structure of the given structure. So in this structure of the given crystal can be assumed or determined by using the Bragg's condition, nothing but 2d sin theta is equal to n lambda, no doubt. In this method is also we are using the diffraction condition, that is called as 2d sin theta is equal to n lambda. Here d is nothing but interplanar distance, theta is nothing but angle of incidence, n is nothing but order of the spectrum, lambda is nothing but incident wavelength of the rays. Particularly we are using the rays are X-rays, no doubt. The X-rays wavelength is approximately equal to 1 angstrom, that is lambda is known. Order, for our maximum simplified calculation we can take the order is particularly first order. For first order means n can be taken as 1. You can take second order, third order, any wish. So based on the order of the spectrum is nothing but for first order spectrum n can be taken as 1. Here theta is nothing but glancing angle and d is nothing but interplanar distance. According to the lattice planes, interplanar distance can be written as d is equal to 1 by square root of h square by a square plus k square by b square plus l square by c square. This is the basic relation among the X-ray diffraction. That Bragg's condition is nothing but 2d sin theta is equal to n lambda. In this crystal, rotating crystal method is also obeys the Bragg's relation, that is called as 2d sin theta is equal to n lambda. In rotating crystal experiment, the experimental arrangement like this. This is the structure or experimental arrangement of rotating crystal method. So in this crystal structure arrangement there are existing two holes, pinholes are existed. One pinhole is used to X-rays entering hole and another pinhole used to diffracted X-rays leaving the condition. And entire this structure is which is in the cylindrical form. Inner of the cylindrical form you are plating the photographic plate. That photographic plate is used to identify the diffracted beam of X-rays collection. So the diffracted X-ray beams are diffracted to some region. That region part is collected by using photographic plate. So photographic plate is inside the cylindrical structure. Inside the cylindrical structure. So what the crystal structure is calculated or assumed, that crystal must be placed particularly middle point on the spindle. Spindle is nothing but this is the spindle. On the spindle you can place the one crystal like this. If the spindle is rotated, crystal is also rotated. By rotation of the crystal you can identify the structure of the crystal. So particularly First, you are placing the 0 degrees, rotating the crystal by 360 degrees, 1 degree, 2 degree, 3 degree. By rotation of angle and angle of X-rays are matched, on that way diffraction pattern is obeyed. Okay, you can instantly the X-rays on the crystal, the rotating angle and glancing angles are matched. On that condition, they can obey the Bragg's relation. That is nothing but 2D sin theta is equal to n lambda is obeyed. That 2D sin theta is equal to n lambda is obeyed. On that condition, Bragg's condition is occurred. So Bragg's condition is obeyed. Bragg's condition is obeyed. So on that condition, diffraction is occurred with respect to lattice plane. So in this crystal structure, first of all, you can entered or you can incidenting on the X-rays by X-ray tube. Already we shown X-ray tube in experiment number 1, lay method and X-ray spectrometer method. We are using the X-ray tube. On X-ray tube, the X-ray tube gives the X-rays. So this is the X-ray. So this X-ray is enters to the pinhole of this structure. The X-rays are entered like this. These X-rays are incidentting on the crystal. The crystal must be placed on the spindle. So the spindle is rotated. This is axis of rotation. I am showing the axis of rotation. Particular rotation is anti-clockwise direction, counterclockwise, anti-clockwise, otherwise counterclockwise. The words must be remembered. Anti-clockwise. This other name of anti-clockwise is called as counterclockwise. So on the diagram, I am showing the rotation of the spindle is anti-clockwise. So the spindle is rotating like this. The spindle is rotating like this, anti-clockwise. So spindle is rotated. The crystal is also rotated in the anti-clockwise. So rotation by rotation, the X-rays are incidentting on the crystal. At that position is changed. The glancing angle is also changes. So lattice planes like this. We are taking the lattice planes. You can incidentting on the X-rays like this. The crystal is rotated nothing but the X-ray lattice planes also rotating. So particularly at theta is equal to 0 degrees, all lattice planes like this. Suppose you can rotate by 1 degree. So the lattice planes is maybe like this. The X-rays are incidentting like. So at a particular angle, theta must be changed. So the incident angle, rotating angle is matched. On that matching condition, they can obey the Bragg's relation. 2D sin theta is equal to n lambda. This condition is obeyed. On that condition, this X-ray is diffracted like this. This is diffracted X-ray. This diffracted X-ray is observed on the photographic plate. Observed on the photographic plate. That photographic plate observed diffracted beams. What structure is existed? Depending on that structure, we can clearly explain the structure of the given structure of the given crystal. So this rotation crystal is mainly used to determine the actual structure of the given crystal. Okay, so this spindle is very important. This spindle is maybe rotated either clockwise or anti-clockwise. According to diagram, I am showing the rotation of spindle is, or axis of rotation is anti-clockwise. If you interested, this rotation can be taken into clockwise also. There is no change. There is no change of rotation. So if the change of rotation changes, there is no clear data missing. So particularly rotation is very important. For what condition? Bragg's condition is applicable. Bragg's condition is nothing but 2D sin theta is equal to n lambda. If the Bragg's condition is obeyed, on that Bragg's condition, they can create the diffraction pattern. Lattice plane by lattice plane, the diffraction pattern is occurred. On that condition, you can obey the Bragg's condition. Based on Bragg's condition, based on incident angle, we can clearly explain the structure of the given structure. So this is the actual crystal structure. Nothing but rotating crystal method. this method is applicable. The diffracted beam of X-rays are observed on the photographic plate as like this. I am drawing one by one. Suppose you have the lattice planes. Lattice planes is nothing but a line or plane passing through lattice points. So I am drawing the crystal. Crystal is nothing but combination of lattice points. So otherwise the combination of lattice planes. So I am drawing. So I am drawing the lattice planes. All lattice planes are parallel to each other. The neighboring distance between two successive lattice planes or lattice planes, the distance can be taken as, what is the distance? The distance is nothing but interplanar distance. This is the lattice planes. So here there is no diffraction occurs. Is nothing but the incidence X-ray is exactly incident in between the lattice planes. So there is no particular rotating crystal is nothing but the crystal is rotated like this. On that condition, all lattice planes are parallel to each other. In this way, X-ray is also incident parallel to the lattice plane. The X-ray is incident like this. The X-ray is going to interspacing. So there is no deviation. At that condition, they can create the central maximum. Suppose this crystal is rotated, you can instanting of X-rays like this. So at this point, instantly diffraction occurs. On that way, the plane by plane, you can observe clearly all conditions are drawn in a curved point. Like also another one. You can take this is the plane 0, one plane, second plane. This is the central maximum to top planes. Central maximum to bottom planes. -1, -2. This is the rotating crystal pattern of diffracted X-rays. The diffracted X-rays like this. This can be taken as certain according to quantum numbers. L is equal to 0, L is equal to 1, L is equal to 2. Here L is equal to -1, here L is equal to -2. This is the diffracted X-rays pattern. At what condition the diffraction is not occurs? Particularly the diffraction is not occurs is lambda by 2D value. Lambda by 2D value always be greater than L. The L value is always be less than lambda by 2D. At this condition, there is no diffracted beams are observed. You can change this condition. You can determine the interplanar distance. Nothing but the Bragg's relation is 2D sin theta is equal to L lambda. According to this experiment is used to determine D value. D is equal to L lambda by 2 sin theta. Once D is calculated, then you can calculate the A value. After calculation of A, you can determine the next one. You can determine the number of lattice points. Per unit cell. Depending on number of lattice points per unit cell, automatically you can clearly explain that the structure of the structure is simple cubic or primitive, otherwise face centered, otherwise body centered cubic. So according to this experiment is also used to clear explanation about how to determine, how to give the entire information about the crystal structure. So this rotating crystal method is used to easily calculate or easily determine the structure of the crystal. So from this experiment is repeated, on repeated observation you can calculate the D value. Once D is calculated, depending on D you can calculate the lattice constant. Lattice constant calculation completed, after that you can find out the number of lattice points per unit cell. Hence, At what condition number of lattice points per unit cell is calculated? Depending on that value, the structure of the cell is easily identified. If n is equal to 1 is observed. If n is equal to 1 is nothing but the structure of the crystal of the unit cell is simple, cubic or primitive. Suppose on calculation you get the result is n is equal to 4. The number of lattice points per unit cell is 4. That is particularly face-centered cubic structure. Suppose n is equal to is observed. If n is equal to is nothing but the structure of the cell is body-centered cubic structure. So experiment number 1, experiment number 2, experiment number 3. Up to these 3 experiments are used to determine the crystal structure. In these 3 experiments, the structure of the crystal is easily identified calculating of D value. So experiment number 1, experiment number 2, experiment number 3 used to determine the interplanar distance. After interplanar distance is calculated, depending on D, you can calculate the A value. After calculation of A, you can determine the number of lattice points per unit cell. Once number of lattice points per unit cell is getting, depending on getting value, the structure of the cell is easily identified. Either simple, cubic, body centered, face centered, easily calculated. So up to 3 experiments, the solid must be taken, otherwise the crystal must be taken in the solid form only. So experiment number 1 is Lay method, experiment number 2 is X-ray diffraction spectrometer, experiment number is rotating crystal method. Up to these 3 experiments, the taking crystal must be in the solid form. So once you can take the crystal is in solid form, that solid structure can be obtained by using any one of the 3 experiments, Lay method, X-ray diffraction method and rotating crystal method. By using any one of the 3 experiments, you can easily identify or determine the number of lattice points per unit cell or structure of the cell. That is the experiment number 3. After completion of experiment number 3, we are going to the next experiment. That experiment is powder photograph method. Powder photograph method. Next method and last method of crystallographic method is, fourth method is powder photograph method. Powder photograph method. In this method is used to determine structure of the crystal. Structure of the crystal, no doubt. Particularly the crystal which is in the form of powder, which is in the form of powder. What is powder? Powder is nothing but crashing of crystal into tiny particles. So the crystal is crashed. The crystal is crashed into very, very tiny particles. The tiny particles combination is, which is in smooth form. The smooth form of tiny particles is nothing but powder form. So the crystal can be taken in the form of powder form. So this powder form crystal structure can be determined by using powder photograph method. So in this powder photograph method, we are using the diffraction condition. What is the diffraction condition? The diffraction condition is 2D Sin theta must be equal to n lambda. So here also using the diffraction condition. For diffraction method, we can use the rays must and should be X-rays. So here also use the X-ray beam. So X-ray beam is collected from X-ray tube. No, the collected from the X-ray tube. The wavelength of X-rays must be equal to 1 angstrom. The wavelength of X-rays must be used to 1 angstrom. So in this powder crystal method, you are using the X-ray pattern. In this X-ray pattern or installing on the powder crystal, on the powder crystal they occur the diffraction phenomena. Once the diffraction phenomena is occurred, then that crystal must obey the diffraction condition. The diffraction condition is 2d sin theta is equal to m lambda. Based on this diffraction condition is obeyed, you can determine the interplanar distance. First of all, you can calculate the interplanar distance. After calculation of interplanar distance, you can determine the lattice constant. After calculation of lattice constant, you can calculate the number of lattice points per unit cell. Once the number of lattice points per unit cell can be determined, you can easily identify the structure of the crystal is either primitive or simple cubic or base centered or body centered or face centered cubic structure. Any structure is identified based on number of lattice points per unit cell. This is the basic introduction about the powder photograph method. So in this powder photographic method, we can take the crystal must be in the powder form. Powder is nothing but crashing of crystal which is converted into number of tiny particles. This number of tiny particles is nothing but which is in the form of very smooth form, because there is no friction among the tiny particles. Friction is very low, nothing but they can easily smooth value. So the smooth form is nothing but powder form. In this powder form crystal structure can be determined. The method is powder photographic method. In this photographic method is also using the diffraction condition. That is the powder photographic method. So we are first going to experimental way. So experimental arrangement can be drawn. So in this experimental diffraction pattern, X-ray diffraction is existed. So we are need to X-ray tube. This is X-ray tube. So based on this X-ray tube, the X-rays are incidenting. So the X-rays are liberated like this. Number of X-rays are liberated. So according to your powder photographic method, need to monochromatic X-rays. Monochromatic X-rays, particularly we need to single beam of X-rays. Here I am drawing 4 beam of X-rays. For this purpose, I am showing one filter. I am taking one filter like this. So in this filter, we are incidenting number of X-ray beams. I am showing 4 beam of X-rays are incidenting. This is filter. This filter I am using to, the output of filter is monochromatic single X-ray. So out of these 4, only single X-ray beam is coming out from the filter. So this single X-ray beam is passing through 2 narrow slits. Slit S1 and slit S2, because these slits are used to, this monochromatic single beam can be passed in the straight path, does not deviate to at any point. So that monochromatic X-ray beam is passing through what the crystal structure is observed. That crystal can be placed here. I am taking the crystal. B. This crystal can be placed here. I am taking the crystal. B. This crystal can be placed here. I am taking the crystal. C. I am taking the crystal. D. I am taking the crystal. E. I am taking the crystal. F. I am taking the crystal. G. I am taking the crystal. H. I am taking the crystal. I. 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 I am taking the So this monochromatic beam is incident on this crystal C. This crystal C. Around the crystal I am placing one circular scale camera. This is circular scale camera. So on the circular scale I am placing one camera. This camera is rotating around 180 degrees left and right. 180 degrees left and right. You can observe. Suppose X-ray beam is incident on this is there is no diffracted. The X-ray is going very straight path. Once the X-ray is diffracted like this and also like this, making an angle here 2 theta. So this is the arc form, circular form. Particular this point to this point. The distance can be taken as S. The distance can be taken as S. This is diffracted ray making an angle 2. This is also same diffracted ray. So this angle is also 2 theta. So total angle among the arc length SC is total angle is 2 theta, 2 theta is nothing but total angle is 4 theta. This is complete structural arrangement. This circular is nothing but photographic plane. Photographic film or photographic plate. So by using this camera I am collecting the diffracted beams. At what angle is diffracted? At what angle is diffracted? I am calculating. According to this experiment, I am calculating S value. So each and everyone knows angle definition is arc length by radius. So this is can be taken as center. This is radius r. This is also radius r. Here angle is 2 theta. 2 theta is nothing but 4 theta. Arc length I am taking is radius r. Then radius r can be taken as S by 2 theta. Otherwise the diffracted angle theta is equal to S by here 4 theta. So the angle theta is equal to S by 4 r. This is also written as theta is equal to arc length by 2 times of diameter capital D. So the diffracted angle can be measured. Theta is equal to arc length by 4 times of radius. 4 times of radius. So according to that value I am calculating. So this is the experimental way to determine the angle theta is equal to S by 2D. So this circular photographic plate taking rectangular form, particularly you are taking the rectangular plane sheet, nothing but you can taking the rectangular plane sheet like this. I am clearly explaining the photographic plate. First of all, I am taking one square photographic plate like this. This is the square. So the X-rays are not diffracted. They can create the central dark spot. Know that. Central dark. According to Lay pattern, central dark spot after they can create the circular fringes like this. Again. Actual photographic plate is like this. So but according to our experiment, I am taking the circular photographic plate, the shape of the photographic plate which is in the rectangular form. Nothing but rectangular form is nothing but this square form is cutting into rectangular form. So I am cutting like this. I need only that rectangular form. That rectangular form is nothing but this is the photographic plate fringes pattern. So particularly this photographic plate fringes pattern observed like this. This is exact photographic plate 1. This is central bright fringe. The distance this left and right part is called as diameter D. After that you can take second to second. This can be taken as D1. In a similar D1, D2, D3 so on. So here a straight line is formed. Here also straight line, nothing but up to straight line. Here the angle of rotation is theta must be less than 90 degrees. At what the straight line is existed, at that is theta must be equal to 90 degrees. This converging path, this is occurred at theta must be greater than 90 degrees. On the calculation of theta, what you get, theta must be equal to arc length by 4r. So the Bragg's relation is 2d sin theta is equal to n lambda. Based on this, d value can be calculated n lambda by 2 sin theta. Theta is nothing but d is equal to n lambda by 2 into sin of theta is nothing but s by 4r. This is the interplanar distance calculation by using powder method. This formula can also written as d is equal to n lambda by 2 into sin of s by 2 times of d. Why I am representing in terms of d is nothing but according to photographic pattern is observed, you can easily determine the d value. You can easily determine the d value as compared to capital R radius. So on that way, d value can be calculated. D is equal to n lambda by 2 into sin of s by 2d. Once d is calculated, first part you can determine the d value. After determination of d value, you can calculate the small a. After calculation of small a, you can determine the number of lattice points. Number of lattice points per unit cell. Number of lattice points per unit cell. So what the number of lattice points per unit cell is calculated? That value is very easy to calculate. The structure of the crystal is either primitive or face centered or body centered cubic structure, easily determined. This is the powder crystal method. This method particularly used to determine the crystal structure must be in powder form. Must be in powder form. This is the powder method form. So up to this we are clearly understood how the crystal structure is determined. The crystal structure is determined by crystallographic methods. How many methods are there? Completely 4 methods are there. One is Lay method, second one is X-ray diffraction spectrometer method, third method is rotating crystal method, fourth method is powder crystal method. Based on these 4, we can easily determine the crystal structure. In entire 4 methods, we are following the only single way. That is, the method is used to calculate or determine the theta, otherwise d value. So once d, interplanar distance, is calculated, depending on d, you can determine the lattice constant value, a value. Once a value is calculated, you can easily determine the number of lattice points per unit cell. Number of lattice points per unit cell. Once the number of lattice points per unit cell is calculated, depending on that value, either n is equal to 1 is getting, otherwise n is equal to 4, otherwise n is equal to 2. Based on this n value, we can easily determine the structure of the crystal is either simple cubic or primitive, otherwise face centered cubic structure, otherwise body centered cubic structure. The last method, nothing but powder crystal method. This method is used to particularly the crystal which is in which form? The crystal which is in powder form. Powder form is nothing but the crystal consisting of number of tiny particles. Number of tiny particles is nothing but the particle does not orderly arranged. Does not orderly arranged, nothing but the crystal must and should be non-crystalline, nothing but amorphous solids. Nothing but the powder crystal method used to determine particularly amorphous crystal structure. The first 3, Lay method, rotating crystal method, X-ray diffraction method, is used to determine the crystalline solids or crystalline materials. That is, the fourth method is particularly used to determine the amorphous solid, which is discovered by Debye, and Stirrer method. This powder crystal method is also called as Debye and Stirrer method. Debye and Stirrer method. So that is the methods through used to determine the structure of the crystal. And the last one in this crystallographic method, uses of X-ray diffraction. In entire 4 methods, we are using the diffraction methods. They can obey the Bragg's condition. Nothing but 2D sin theta must be equal to n lambda. The Bragg's relation is 2D sin theta is equal to n lambda. Based on this condition, this is how the uses of X-ray diffraction. The uses of X-ray diffraction is, first one is to differentiate crystalline or non-crystalline materials. Out of 4 methods, 3 methods are used to determine the structures must and should be in crystalline form. One method to use it to determine the structure of amorphous. On that way, you can easily distinguish either crystalline or amorphous solids. Second one, to determine the orientations of the single crystal. Single crystal method is used for crystal experiment, nothing but method 1 and method 2. Method 1 is Lay method, method 2 is X-ray diffraction method. In both the methods, you are using the single crystal. At the single crystal, you can determine the theta value. So theta is nothing but glancing angle. That glancing angle indicates the rotation. At what rotation is created, that orientation can be explained. After that, to determine the structure of the crystalline solid, entire method 1, 2, 3. These 3 methods are used to determine the structure of the crystals. The crystals must and should be crystalline form. Crystal is nothing but the atoms or lattice points are arranged particularly orderly arranged. Orderly arranged, nothing but side by side atoms are equally distinguished, equally spaced. So orderly arranged solids can be determined by using X-ray diffraction method. To determine the electron distribution in the atom, you can take any one of the atom. that atom, the inner structure, nothing but electrons, how arranged. In 1s shell, how many electrons are there? In 2s shell, how many electrons? 2p shell, how many? That number of electrons are occupied, clear vision can be explained by using X-ray diffraction. And the last one, to decide texture of the polycrystalline materials. Polycrystalline, nothing but they consisting of number of crystals. Based on number of crystals, you can easily clearly explain the structure, number of lattice points per unit cell. That is also clearly explained by using X-ray diffraction method. These 5 are very important uses of X-ray diffraction method. So up to this we are discussed only crystallographic methods. That crystallographic methods are used to determine the structure of the crystal. So entire 4 methods are there. After completion of 4 methods, we can easily note down the uses of X-ray diffraction. This is crystallographic methods. Okay. After completion of this, we can go to the some depth of the subject of the crystallography. Particularly in your MMP, Mathematical Methods of Physics, Fourier analysis is existed. Based on Fourier analysis, what is the scattering amplitude calculated? Scattering amplitude is nothing but you can instead in the one light ray beam. This light ray beam is some part is reflected, some part is transmitted. This transmitted amplitude can be calculated by using Fourier analysis. In our next class, we are going to discuss scattering amplitude, how the scattering amplitude is calculated. In our next class we are discussing. Okay.